All right, tonight what we're going to be talking about is how is the periodic table divided into even more subgroups. So the areas of the periodic table that we've got is one way that we can separate them is by metals, nonmetals, and metalloids. So if you look at the periodic table that I provide you at the bottom of this page, you'll notice that the metals are here, metalloids are the purple, and nonmetals are orange, but make sure you remember that hydrogen is also considered a nonmetal. So if you were to focus on just the green, you'll notice that it takes up the majority of the periodic table. So what does that mean? Is that the majority of elements, actually up to 80% of them, are going to be metallic in nature. So when you think about what is a metal, you think about their different characteristics. Well, one characteristic of being a metal is that it is a solid at room temperature. How do I know that it's a solid at room temperature other than by looking at it? When you look at the periodic tables in the classroom, what you'll notice is that black letters, if their letters are black, it's not how you spell black. If they're black, then those represent solids at room temperature. So obviously most of the metals are the black. If they are blue, they represent a liquid at room temperature. Remember, this is at room temperature, so what we normally are at in the classroom. And then reds are gases at room temperature. Okay. The only other one, so we've got solids, liquid, and gases. We've represented all the various states of matter that we see at room temperature. The only one that we're missing are that you'll notice that some of the periodic table letters or elements are just outlined. And what does those mean? Those means that means that they are man-made, meaning that they are not found in nature. They are actually made in a lab. So what are some other characteristics other than being a solid? Well, one characteristic is that it can conduct electricity. Another is that it has luster or shine. It is ductile, which means it can be bent into wires. And then it is malleable. How do I remember malleable? It means that it can be pounded into thin sheets. I think of the word mallet. And what does a mallet do? It beats things in to make them thinner. So that's how I remember malleable. The other way that I remember characteristics of metals is I always think of aluminum foil. And what are the characteristics of aluminum foil? And that's going to be your metallic characteristics. So it's a solid. It can be pounded into thin sheets. That's what the aluminum foil is. Obviously, it's extremely shiny. And then if you know anything about the history of electricity, they actually used to make electrical wiring out of aluminum. And why? Because it was extremely cheap, but it also could conduct electricity and be made into wires. So they did switch it around the 1970s and change them into more of copper wiring. And the reason why they did that was because aluminum does tend to start fires more often than copper did. So they made that big switch. So when you then look onto nonmetals, which is another major subgroup of the periodic table, what you want to do is you want to think of all the characteristics of a metal and then go with the opposite, and that's the characteristics of a nonmetal. That's why it's called nonmetals. So first off, instead of being solids, they are typically gases at room temperature. Not all of them are gases, but the majority of gases are going to be nonmetals. And then their properties are once again the opposite of what a metal would be. So they are brittle, they are non-lustrous, so they are not shiny. They do not conduct heat or electricity very well. And then the last subgroup of the periodic table when you're talking about metals and nonmetals are these metalloids. And what are metalloids? Well, metalloids are smack dab between metals and nonmetals. So what are their characteristics? Well, it's a blend of both of them. You have non-metallic characteristics and metallic characteristics for these various elements. Okay, so basically it's when metals and nonmetals had a baby, their characteristics would make up a metalloid. So what I want you to do is take out your periodic table and I want you to write these down. So first you're going to need to draw what I call the staircase. Okay, so I will be referencing the staircase throughout the entire year. So make sure that you understand that this is the staircase that I'm talking about when I talk about a staircase. Start to the left of boron right here and then make it down and over 1 each time, and that's your staircase. What does that staircase separate? Well, everything to the left of it represents your metals. Everything to the right of it represents your nonmetals, which I'm going to abbreviate as NM, and anything on it will be your metalloids. Okay, now I will never ask you a specific question about which one is a metalloid. I will ask you more broadly speaking where are your metalloids found. I do want you to note that this guy, hydrogen, is considered a nonmetal, even though it is to the left of that staircase. So these groups can be even further divided into their families or groups. Remember, families or groups are the columns. The first column I'm going to talk about are your alkali metals. Alkali metals come from, the word alkali comes from the word base. And what happens is when these elements in this first column, not including hydrogen, react with water, they actually form a solution that is basic in nature, which we'll be talking about more come the end of the year. They are very soft and you can cut them actually with a knife. So they're not that solid, hard substance that you couldn't cut with a knife that you need like a saw or something to do. Instead, think of more of like butter and you could cut it with a butter knife. And they are the most reactive metals. And why are they the most reactive metals? Well, it all comes down to valence electrons. So if I look at the valence electrons of the alkali metals, okay, so I've got my little rings, and I'm going to do lithium. So lithium has 3 electrons, only one is a valence electron. This one valence electron will be readily lost, more so than one with 2 valence electrons, 3 valence electrons. The fewer valence electrons you have, the easier they will be to lose. Okay, so therefore if you have one, you will lose it extremely easily. And reactivity is primarily due to how reactive or how readily an electron is either lost or gained. So we're talking about metals, it's how likely is it to be lost. And everything in that first column will be lost really easily. And everything in this second to last column for the nonmetals will be gained really easily. So the alkali metals are the most reactive. Okay, and the reason why is because it only has 1 valence electron. Then we've got the alkaline earth metals. Alkaline earth metals also form bases. That's where you get that alkali again, but it's not as well, so that's where they add on this earth metals to differentiate. And they have 2 valence electrons. Halogens, if you think of the word halogen, it actually means salt forming, which I wouldn't expect you to ever understand or know. But if you think about what a salt is, we know of one of NaCl, and Cl is a halogen because it's in this last column. And what that means is that most salts that we find on Earth actually have one of these components as a part of it. So therefore, they came up with the word halogen because these are the salt-forming elements. They have 7 valence electrons. Because they have those 7 valence electrons, they are the most reactive nonmetals. Why? Because nonmetals want to gain electrons, and all they need to do is gain 1. So that's extremely easy compared to gaining 2 or gaining 3 or gaining 4. So these are your most reactive nonmetals. All right, then the last group we're going to talk about right now are these noble gases. And what are noble gases? They are this last column, and they do include helium in it. Helium is known to have a duet, which means 2 electrons, valence electrons. And these guys, everything below that is 8 valence electrons, which means that they have an octet. Because every single element wants to have 8 valence electrons, or have 0 basically, 8 valence electrons, noble gases that already have that will never ever want to gain or lose an electron. And things reacting come because they want to gain or lose an electron to make them have this perfect octet. Well, the noble gas column already has that perfect octet, so they will never ever 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 react. They are extremely stable. They do not react, and they are known as inert gases. Why are they known as inert gases? Inert means not reactive, and gases means that they're a gas. And lo and behold, all of these are red, so they are all noble gases. All right, you can also divide, so we've got metals, nonmetals, metalloids, we've got the different families, and now we've got this group called representative elements. They are seen, if you look at a periodic table, above the periodic table, you will note some periodic tables have these letter A's. That represents a representative element. What a representative element does is it's a group of elements that actually show all the properties that can be exhibited in the periodic table. So radioactive, solids, liquids, gases, loses electrons, gains electrons, highly reactive, non-reactive, things like that. They're found in the S and P sublevels, which we will talk about in a further unit. But if you ever see a group A element, they are also known as representative elements. Just like your representative that is elected should represent everybody, all of its constituents, these group A elements should represent all of the characteristics that elements can have. So if it's not a group A element, which are these guys that I'm circling right now, or a representative element, then they are either a transition metal, which is this group right here in the center, or these guys, which are known as the inner transition metals. Okay, so transition metals is the D sublevel. Once again, I will be talking about this more later in another unit, but right now I just want you guys to understand that these are transition metals. They're not considered representative metals. And then we have these last group down here of last two rows, which are the inner transition metals. They are known as the F sublevel, which once again, you really don't have to worry about much. What I do want you to know is that that first row are known as the lanthanide series or lanthanides, and the last row are known as the actinides or actinide series. Now, they used to be known as the rare earth metals, as you've seen here, and it kind of has stuck, but actually, if you look at the lanthanides, a lot of those elements are commonly found where they thought they weren't found in previous times. They didn't think that, they thought that they were extremely rare, but they found over the course of more mining and more digging and more research that those lanthanides are actually fairly common comparatively to some other elements that we have. All right, so what I want you guys to do is I want you guys to take out your periodic table and I want you to color them, okay? So following my colors, you do not need to use exact same colors, just make sure that the groups are the proper ones. I want you to label and box out your alkali metals, your alkaline earth metals, your transition metals, which is this whole block. You've got your inner transition metals, which is down here. You have your lanthanide series, which is this top one, actinide series here. You've got this like cyan group. Don't worry about this. This doesn't really have any names. We're just considering the metals. You've got your metalloids, you have your halogens, and you have your noble gases. Those are the primary ones. What I also want you to note is that if you look at the atomic number, okay, so if you look at these atomic numbers, we've got 57 and 89. What happens, and you see these little stars and plus signs, what happens is that this whole group of inner transition metals should actually fit up right here, okay? But if I did that and I drew my periodic table, it would look something like this. Really, really long, then it'd go up here, then it'd go up here, and then it'd get this. So what they do is instead they cut this whole section out and they move it down so that it can be consolidated on in a shorter amount of space. Plus these guys are not used as often as, especially in this class, as the primary ones up here. So that's why they actually take that section out and that little inner transition metals are on the bottom of the periodic table. All right, hopefully you understand the various families, metals, nonmetals, metalloids, and representative elements. Have a great evening.